Hi. So today's presentation is about features that are on the near-term, well, mostly near-term roadmap. They're not, I'm trying to avoid sort of pie-in-the-sky features that have no chance of arriving in the near future. But sort of this is maybe 1 or 2 years out kind of target. Oh, wrong way. So quick overview of how features get into Lustre, some of the features, and there are some presentations that are also being delivered later in the conference, so I'm not going to really cover those ones. The feature submission process, we're trying to follow a train model so that every 6 months we have a major Lustre release, and for the first 3 months of the development on any given feature is an open window for landing features and patches of all types. At 3 months, we have a cutoff for new feature development. It's important to note that if people want to get features in, and we're obviously encouraging of everybody trying to contribute to Lustre, but you have to make sure that your patches are available and tested and inspected before the 3-month cutoff. So that's not the day when everybody should submit their patches to be included. 2 months we have before the release. We want to get documentation and test plans and everything like that for features done. And 1 month before the release is cut off for only bug fixing and critical issues being addressed. So we're trying to have a reasonably stable process for adding these new features. And it's worth mentioning, this is all prediction of the future, and so the features that are listed here are not necessarily all guaranteed to be in any given release, although I've tried to annotate them with the intended release. So the first few are fairly clear because they're already well underway in terms of development, and the patches are mostly available or at least underway right now. The distributed namespace phase 2, that's going to allow asynchronous updates across MDTs, and more importantly, it's intended to allow recovery if one MDT or some combination of clients and servers fail while they're doing these distributed updates. LFS check phase 3 is consistency checking for distributed, essentially remote directories on other MDTs or for Stripe directories on other MDTs. UID and GID mapping, that's a feature from Indiana University that is intended for WAN usage or where campuses are administered by different groups of users or administrators, and it allows, on the server side, it will transparently map the user and group so that clients can have their own private view of what user IDs are. What's a little bit interesting about that one, actually no, I can talk more about these in detail later. Some of the later ones you'll see they don't have version numbers beside them, and that's because these are things that people are working on, not quite sure when it's going to be ready. It doesn't mean that they're not going to be in a particular release, it's just that we don't want to tie people down onto specific releases. And these presentations that are just listed here quickly are ones that have other presentations that are already being given during the conference, so I'm not going to cover them. So the later ones, the designs are done, but no current implementation being worked on. So the first one, distributed namespace. So what that is Stripe directories of phase 2. So phase 1 was included in Lustre 2.4, I think, and that had remote directories, so you could scale at the directory level the namespace and performance and size. Phase 2, that's in 2.6, is Stripe directories and a tool that allows you to move the Lustre file layout to a new inode on a new MDT without having to copy the data. So it allows you to essentially to do rebalancing. It's worth mentioning that D&E is still, it's not doing any dynamic load balancing across MDTs. This is relatively static load balancing at the directory level, or you know, like regular Lustre file layouts, you specified a Stripe directory at directory creation time. But in 2.7, so 2.6, you also don't have cross MDT renames or hard links. So that's going to come as part of the asynchronous updates in 2.7, because without the recovery model, it's too complicated to do that. Just a little graph at the bottom that shows 1, 2, 3 MDSs with 1 or 2 MDTs per MDS. And you know, as we would hope, this is for a single directory that you can get fairly good scalability. On the test system, that this was done on the OpenSFS test cluster, it went from 1 MDS and 1 MDT at about, say, 7,000 creates per second up to about 27,000 creates per second with 2 MDSs or 2 MDTs on each of 3 MDSs. So it's a pretty good scalability. Lustre file system check. This is a project that's been going on also for a few years, and it's been split up into a number of phases for you know, getting the features out into use. So the first phases would give you local consistency checking. Phase 2, which was just landed in Lustre 2.6, is the MDT OST consistency checking. So that's the first kind of distributed checking for files and their layouts between the MDS inode and the OST objects. And so that's essentially in 2.6 is the final death blow to the old LFS check tool, which is happy in my books. This is all, the good news also with LFS check, the new one, is that this can all run while the file system is active and in use, and it runs in the background as a MDS and OSS threads that are communicating over Lustre RPCs. And so it's, it does still depend for E2FS check, it still does depend on local file system consistency checks. So if you have E2F or like ext4 or LDiskFS, you still have to have a E2FS check run, or you know, at least be confident that your local file system consistency is not disastrous. But for ZFS, for instance, it can run completely online. And the phase 3, which is coming up in 2.7, is adding the cross MDT consistency checks for remote directories and Stripe directories. And we'll link in, you know, orphaned files on remote MDTs into lost and found. There's a top level directory under .lustre in your mount point, so it's .lustre/lost plus found, that you know, orphan files in phase 3 and orphan objects in phase 2 get linked into, so that you know, administrators can clean them up or you know, free up their space as needed. So UID mapping is a project from Indiana University, and essentially it implements a bunch of quite useful infrastructure. The first one is node maps, which give us a way to group by name, you know, some number of clients by their NIDs, and then for each node map, you can instantiate mappings for both UIDs and for user IDs and group IDs for each node map. And so like I mentioned earlier, this is useful for administering remote, allowing remote systems with different user databases to connect to a shared file system, which is very useful if you don't control everything, all of the clients that are connecting to your file system. And so parts of that infrastructure have gone into the 2.6 release. Unfortunately, the part that actually does the mapping, so you can instantiate node maps, you can instantiate the ID maps, but the part that does the mapping didn't make it in with 2.6. It has to do not only the regular RPC mapping, but it also has to handle ACLs, which is more complicated. It has to handle quota and things like that, because the IDs that are stored on disk on the servers need to be consistent with the remote systems and the local systems. What's also worth mentioning, and it's not, don't confuse me, it's not part of this feature, but this is almost enough to give you something like essentially segmentation of a single file system, because you can create disjoint sets of user IDs and then squash the IDs outside of your mapping. So this is infrastructure that might one day be useful for using Lustre in, let's say, a cloud or something like that. But it's not listed on the slide. It's just an interesting observation if somebody wants a cool project to work on. So another feature that we're working on with Fujitsu has been requested for quite a long time and finally come to fruition, is OST-specific set stripe that allows you to specify exactly which OSTs a given file is on. I mean, previously you could specify the first OST and then the MDS would pick usually following ones. But this gives you very fine-grained control. At Fujitsu and on the K computer, they have thousands of OSTs, and they're local in the cluster where they're attached. And so depending on which node you are, you want to be able to specifically select OSTs for network locality. And I think this is useful for other kind of things. You can specify a comma-separated list, or you can specify a range of OSTs. Just a nice little add-on. So Kerberos, along with another feature from Indiana University, there's been quite a resurgence of interest in using Kerberos for authentication and encryption over WAN. And at LAD last year, there was a presentation about all of the things about Kerberos that don't work, but thanks to a number of members of the community, Indiana and others, there's been a lot of work to get Kerberos, some of the infrastructure working again, and Xyretex has indicated interest in reviving Kerberos and making it usable in a more robust way. So the shared key crypto, which is something I'll talk about in a few slides, they're both going to use the same infrastructure, and so it's going to mean better testing, and we hope that Kerberos won't stagnate anymore. Another feature from Xyretex that they're working on is adding in the T10 diff, or it's now called PI, to add end-to-end checksums through the stack. And so there are Lustre level RPC checksums that go from client to server, but this takes it a step further if you have the right RAID controller and or disks. You can get checksum verification down at the disk level to make sure that your cables and your controllers, HBAs, all of those things haven't corrupted the data. And so that gives you immediate feedback on data corruption, unlike a stored checksum, which you might not notice until you're reading the data at some later point. And so another feature that Ihara had briefly touched on in his presentation was the larger RPC sizes. And so there was, in the testing that he did, there's currently already 4 megabyte support in the Lustre 2.4 and later clients. It's disabled currently by default because we didn't have very good performance measurements. And I know in the past, I think Oak Ridge had done performance testing with 4 megabytes, and under certain use cases, the performance had gone down at that time. I think it was like shared file reads or something like that. There's some contention there. But so 4 megabytes is these days is looking pretty good, you know, to take a good thing, make it better. So we're going to allow you know, work to have up to 16 megabyte RPCs. The protocol support, you can specify what the max RPC size is, but there needs to be more work done on the client and on the server to handle because the RPCs themselves are getting quite large at this stage, and all of the arrays for allocating and managing, you know, a few thousand pages at a time is, you know, there are some problems in the memory allocation. Similarly, on the client side, the I/O engine is currently it will specify, if you specify a large maximum RPC size, then it blocks, you know, all RPC submission until it gets a very large RPC, and that's suboptimal. We'd like it to pick, well, first off, what the actual RPC size maximum is. So if you have it configured to say 32 megabyte RPCs, but you only have it tuned to 1 megabyte, that it's actually submitting 1 megabyte and not what the maximum specified is. And just to make it a bit smarter in the I/O submission. So that's at least based on the testing of the underlying storage, going to 8 megabytes has shown, you know, some improvement, and especially in the highly contended cases like Ihara showed, getting the larger I/O submission in one chunk gives you better performance as the number of threads, you know, the number of threads are increased. So the other feature that Indiana is working on is the shared key crypto. And this is different from, there's actually a presentation at LAD last year about this. So it's different from Kerberos in that you don't need a you know, domain controller. You don't need to have a shared, you know, infrastructure between remote sites, you know, and cooperation among the Kerberos administrators, you know, at one university and another university in order to mount these file systems. So this is something that can be set up by the Lustre administrator, and it uses a shared key to do node authentication, which is different from Kerberos, which is doing user authentication. And the key distribution is external to Lustre. I mean, the Lustre components just assume that clients have a key and servers have a key, and you can match them and you can positively identify, you know, clients that are allowed to connect. And so this is relatively easy to set up. It also makes the testing a lot easier because you don't have to have a Kerberos infrastructure to do your testing. And like I mentioned again with the UID mapping, if you can positively identify clients, you can also partition the clients so that clients that don't have a certain crypto key can't access parts of your file system, right, by using the UID map to squash everybody that's not authenticated. So it's going to use initially the AES 128 encryption, which is, you know, available with hardware support, and so the performance should be pretty good. you know, as much as it can be if you're doing full encryption. And so that's it. There's no, as you mentioned, I mentioned earlier, there's no dates on the last features. But you know, these are actively developed projects. And there may be other projects that I'm not aware of, and it would be great if people who are working on those things could propose them and discuss them on the list so that other people in the community, you know, we don't end up stepping on each other's toes. So if anybody has questions, I'd be happy to answer. Megan.
You mentioned for the LFS that Stripe there was network locality that you could exploit, which sounds fantastic. Is there any work going on for QoS for load balancing monitoring?
Okay, so to repeat the question, I mentioned QoS, locality, network locality. So it's important to note that the network locality, that's specific to the Fujitsu K computer. At the Lustre level, it doesn't yet have any concept of locality. There is, you know, there's a possibility to use things like OST pools to specify at the administrator level locality. But there is a larger desire to get knowledge like that into Lustre. I know for like file replication and things like that, you want to be able to say, you know, allocate one replica on this rack and one replica on that rack. And you can do that through pools and specific, you know, set stripe like this, but it would be desirable to have a bit more smarts at the Lustre level. In terms of QoS, I mean, there's NRS, but that's at the individual server level currently, right? There's QoS on a per user level, or I'm not totally sure. There's a token bucket filter, which is a new QoS policy that I think you can use user ID and group ID, and I think that went into 2.6. I'm not 100% sure. But you know, I think that's the foundation for getting better per server QoS. I think we would need to have something like the gossip protocol that was developed for DEOS to have efficient cross-server communication to be able to do QoS across servers, right? So that you could have a global, let's say a global bandwidth limit as opposed to a throttle on a per server level. But that's no plans to land that yet.
I grabbed the microphone to give you a hard time. I just wanted to point out that the LFS CK work and the D&E work was funded by OpenSFS, while Intel did the work. The bucks came from OpenSFS. Likewise, you mentioned some additional features that the designs were complete. Again, you know, I kind of want to be a butt trumpet here and say, you know, data on MDT, layout enhancement, file level replication, those designs are complete. In addition to a client I/O simplification design, those were funded by OpenSFS. So, you know, those of you that are members, pat yourself on the back. That's an act of bigamy, right? You say, oh, that's a bigamy? Anyway. So, just giving you a hard time.
Go OpenSFS.
Go OpenSFS. and Lustre. Thanks.
Yeah. No, and I mean, it's worth saying that, you know, OpenSFS is a good, you know, a good place to consolidate, you know, funding, but also the requirements, right? To drive features that maybe not any one group, you know, is willing to pay for entirely out of their own pocket, but, you know, to combine the effort and do the development.
I have a question regarding the latest Linux kernel. What are the plans, like running with kernel 3.12 or 3.9? What is like the plan for that? Because we basically run all our infrastructure runs on Debian, and so we now did some experiments with 3.6.11, but only with ZFS support, because the LDIS currently does not work on 3.6. So, what are the plans in this direction?
So there's two things there. One is the vanilla client, right? Starting in 3.12 essentially. So the good news is that it's in the client, and as we move forward 3.14 and things like that, I would say charitably it's largely working. The difficulty is that there was some differences in porting and things like that, and the upstream kernel maintainers, they're essentially don't want us to land any feature patches, but rather only maintenance patches. So the upstream kernel is sitting at essentially what's a Lustre 2.4.5 client. And so the current goal is to, incrementally land maintenance patches to the upstream Lustre until we can assume control ourselves. There's no plans for immediate plans, at least for a Lustre server to land in the upstream client, the upstream kernel, just because there's enough work to be done to fix up the client. There is ongoing work. James Simmons has done a great job getting Lustre to work with the SLES kernel and keeping up with the newer kernels on the server side. LDiskFS, there is a set of patches. I think it's in 3.11 right now? Yeah, so there's a set of LDiskFS patches, and that's again, it's a lot of work to update the patches, and it has to be done, definitely. Let's say when RHEL 7 or something comes out and SLES SP or SLES 12. Right, that there has to be work done to update the patches at those points. Catching the intermediate kernels is more effort than we have people to work on. So, we welcome external contributors to do that kind of stuff. So there is some chance of running with a newer kernel. Like you said, ZFS makes it easier because it doesn't need any patches. But I hope that answers your question largely. Okay.
Okay, that's all we've got time for. Thank you, Andreas.
Okay.